All right, so today we're going to do the bell curve. And this is a picture of the bell curve. And it looks like a bell, if you think of the Liberty Bell or something like that. And this is how you're going to be graded in college. And we'll talk about that more on Monday. But for right now, let's look at what the normal curve or bell curve is. What it does is it has in the middle here average. And then we have these deviations away from average. This one right here is one standard deviation above average. Pretty good. How about this? You can be 2 standard deviations above average and 3 standard deviations above average. Likewise, you can be 1 standard deviation below, 2 below, or 3 below. And it all depends on what we're talking about. If we are talking about height, then this could be the average height, and depending on how tall you are, you can be really tall. We're talking about, I don't know, Shaquille O'Neal tall, or maybe you can be really short. But that's what we're going to be studying, the bell curve. All right, so take the time to pause the computer and write this down. You are going to be required to know the bell curve and all its percentages. So what do these percentages mean? Well, right here we remember this is the middle, so this is average. This is 1 standard deviation above average, and this is 1 standard deviation below average. So 68% of the population is going to be between 1 above and 1 below average. So sorry people, that's us. That's where us everyday common folk land. We're pretty much above and below average right here in the middle. Then we spread it out and we include the next set of populations. So 95% of the people would be between 2 standard deviations above and 2 standard deviations below. And then we get into our extreme cases, the 99.7, people who are 3 standard deviations above for whatever reason, and 3 standard deviations below. I mean, if you think about it in terms of sports, these are our professional athletes up here. They're so good at being above average in sports that there's only 2.5% of them. And you think about it, that's what the common number is. Only 2% of our high school athletes will make it to some kind of pro sport. So it fits the bell curve. All right, so again, pause and make sure you get all these percentages written down. All right, so let's look at this. Take out your calculator and enter this list of numbers in your stat mode. These are 13 students who took a math quiz, and it was a 16-question quiz, and each number here represents how many questions each student got right. We want you to find the standard deviation for this data. Okay, so enter it in a stat list. Put it in list 1. Then select one variable stat. And you want to do it on list 1. And then up will come your list again. The first one being X bar, that's your average. And our average said about 10.15. So on average, the students got 10 questions right out of these 16. We have EX and EX squared, and that's going to be talked about tomorrow in class. But the next thing I want you to look at is S sub X and this little Greek theta sub X. There are 2 types of deviation. One is called sample deviation and one is called population deviation. And yes, it depends on which one you use. Sample, which has an S, is what you use when the data you obtained is from a sample of the population, not the entire population, but only part of it. Think about if you wanted to survey everybody in the school. That's a population deviation. That means you have to ask every single person in the school a question. You'd probably want to do a sample where you get a significant amount of responses, but not everybody in the school. So when you read your question, you have to decide, is it sample or is it population? For example, this is population because 13 students took the quiz and we have 13 responses. So therefore, we're going to use the population. So this is what you would be expected to do. You'd be expected to take your bell curve, and right here you would put 10.15, and then you continue to fill out your bell curve. This is one standard deviation above average. So I take 10.15 and I add on to it 2.38. This is 12.53. And onto that, I'll add on another 2.38. And that gets me 14.91. And onto that, I'll add on another 2.38. And I get 17.29. Now that's a little odd because there are only 16 questions on the test. But that's okay. This is how our data was grouped and fed out. Now we're going to go the other way. We're going to subtract 2.38. So 10.15 minus 2.38 gets me 7.77. From that, I'm going to minus 2.38, 5.39. And from that, we'll minus 2.38, and we'll get 3.01. So this is looking at it, and we would see that this is 34%, and this is 34%, and that 68% of our grades were between 7.7 questions right and 12.53 questions right. And that nobody obviously could get up here at 17 right because there were only 16 questions on the test. So if you go back and look at that data, you'll see that only one person got 16 right. And then all our other data is pretty much in between the 7 and the 12. And that's where 68% of our data lies. And that's what's you're going to find out. That's with anything we measure. Okay, one more problem real quick. A student was doing a statistics project. He went downtown and asked people their ages. After gathering 100 responses, he organized his data into the following. So obviously, this column represents age, and this column represents frequency, how many people responded. I gave you this one as a grouping one. So you can see that we don't really know how old these people are. We just know that 3 people were between 10 and 15 years old. So you would be charged with writing a complete bell curve for this data. So the first thing you have to do is figure out which standard deviation would you use. Would you use sample deviation or would you use population deviation? You would use sample because you didn't ask every single person downtown. You only asked 100, so you sampled the responses. So let's enter this into our calculator. All right, go into Stat. Clear out anything you may have in List 1 or List 2. So in List 1, I'm going to enter the average of this interval. So if I took the average of 10 and 15, I'd get 12.5. And then I'd keep going through the whole thing. If I took the average of 16 to 21, I would get 18.5. And so forth and so on. So 22 would be 24.5. So pause now and figure out the rest of the averages of them. And then in list 2, you would simply type in 3, 15, 12, ... All right, so here's our bell curve. I made it nice and big. And let's start writing in what we got. All right, let me get mine up here. One variable stat. Remember, I want to do one variable stat on 2 lists. List 1, comma, list 2, if that's where you put them. And I got right here for my average 33.02. So that was the average age of people that I interviewed downtown. I'm going to use sample deviation, and my sample deviation turned out to be, well, let's make things easy on ourselves. Let's call it 10.7. Let's round it to the nearest 10. All right, so I'm just going to go to 33.02 and add on 10.7 and find out that this was 43.72. Now I'll add on 10.7 to that and get 54.42, and I'll add on 10.7 to that and get 65.12. Now I'll go the other way where I'm subtracting. So 33.02 minus 10.7 gets me 22.32 minus 10.7, 11.62 minus 10.7 gets me 0.92. Right. Since it said write a complete bell curve, I also have to put in my percentages. So this would be 34%, 34%. This would be 13.5%. And I'll just mirror that on the other side. This would be 2%. Mirror that on the other side. And then 0.5%. Mirror that on the other side. And the last thing you should always do is a title, so I know what I'm looking at. And this could be the bell curve for a sample population of age in downtown, wherever, Sag Harbor, because we didn't say where he was, but we'll assume Sag Harbor. And there you go. So for Monday, I just want you to be familiar with the bell curve and its percentages and what everything looks for, and we'll have a little longer discussion, maybe 10 more minutes on it. See you tomorrow. Bye.